So we're going to take a look at the structure of polymers. Now, polymers are long chain molecules that are formed by individual smaller molecules, or monomers, that link to each other, that form covalent bonds to each other. So we can imagine a number of small molecules bonding to each other, making a longer chain of molecules. And here we have 7 small molecules making a small polymer, but these could be hundreds or thousands of molecules making a very long chain. Now, there are a variety of structural types that can come up when we do this. And one of them is simply what happens if we have more than one kind of monomer, more than one kind of small molecule that's linking together. So if we have 2 kinds of monomers, these red ones and these blue ones, they would be called co-monomers. They're working together to make this polymer. And the polymer that they make is a copolymer made from 2 different monomers. And there are a variety of ways they can come together to make that polymer. So for instance, if we're always alternating one monomer, then the other, then back to the first, then to the second, that's called an alternating copolymer. If instead one kind of monomer is coming together first to form one block, and then the second kind of monomer follows after that, forming a separate block joined together in the middle, that's called a block copolymer. The 2 monomers might come together randomly, and we get a random or statistical copolymer in which there isn't any particular order in which the 2 monomers come together. And just to give you a feel for some of the bigger variety of structural types that are possible, we might have one monomer that comes together to form a backbone, the initial chain of this molecule. And then a second monomer might grow off from that backbone in what's called a graft copolymer. So there are lots of structural types that we can get with polymers, lots of different shapes. But even if we just have one chain, we can get different shapes because that chain has single bonds throughout it that can rotate. And so we can get different conformations of that polymer. And so that extended conformation that we're looking at would exist in equilibrium with a coiled up conformation. It could have all kinds of slightly different shapes just by rotating around bonds. Right? That's just with a simple chain. Of course, we can have branches coming off the chains like we saw in the graft copolymer. But we can also have chains that get connected to each other. So if there's a covalent bond from one chain to another chain, it's called a crosslink. And we refer to a covalent bond sometimes as a chemical crosslink because of that chemical bond. On the other hand, if we have strong intermolecular forces between 2 neighboring chains, those chains are also connected. We call that a physical crosslink because of the reversible nature of that interaction. And all of these different shapes are important in determining the structure of the polymer. So for instance, if we have crosslinks between polymer chains, it tends to make a material much more rigid, much stronger. So the shapes of these polymers and the composition of these polymers are intimately linked to their properties and what the polymers can be used for.